Definition of a derivative. So we're going to start by estimating the slope of x squared minus 3x at x equals 2. And that's at this point right here. So we're going to try to find the slope at x equals 2. We're going to do that by getting average rates of change. What that means is, so your classic slope formula is y2 minus y1 over x2 minus x1. And so you'd find you have your first value, which right here is 2, and your second value, which is 3 right here. You plug them both into f of x to get your y values, and you have these as your x values right here, and then you use that to find the slope. So a better way to write this will be f of b minus f of a over b minus a, where b is your second number and a is your first number. Let's find the average rate of change of f. So here we have the first interval, 2, 3. So you do f of 3 minus f of 2 over 3 minus 2. Okay, so f of 3, if you plug in 3 into f of x right here, you'll get 3 squared, which is 9. 9 minus 3 times 3, which is 0. And if you plug in 2, you get 2 squared, which is 4, minus 3 times 2, so it's negative 2, over 3 minus 2, which is 1. So 0 minus negative 2, that's positive 2, over 1, that's just going to be 2. Yeah, this right here, from 2 to 3, see 3 is right here. So the slope of this line is 2. Now let's try doing the same thing with 2.5. Do f of 2.5 minus f of 2 over 2.5 minus 2. It's best to do this one with a calculator at 1.5 for this one. 2.5 is right here. This line between the 2 and the 2.5 has a slope of 1.5. Now say something with 2.1. Again, we use a calculator for this one. We got 1.1. So let's just erase this here. From 2 to 2.1. The slope between these 2 points is 1.1. Now say something with 2.01. Putting that into the calculator will get you 1.01 as a slope between the points at 2 and 2.01, which is really right next to each other. And notice with these b values, with these second values, we're getting closer and closer to 2. So you find your actual slope at x equals 2. So slopes are approximations of the slope of the line tangent to the graph of f at x equals 2. So the slope at x equals 2. The approximations become successively more accurate as the change in x becomes closer to 0. Change in x can also be written as delta x. And that change in x is basically what's at the bottom here. So up here, the change in x is 1. Down here, the change in x is 0.01. And the closer this gets to 0, the more accurate the estimation of the slope becomes. And so because of that, the slope at x equals 2 can be defined as m, which is your slope, equals the limit as delta x approaches 0 of f of 2 plus delta x minus f of 2 over your 2 plus delta x minus 2. The 2 here is your a value, and 2 plus delta x is your b value. Notice how it looks similar to this. Because we get positive 2 and the negative 2, they'll cancel out, so a better way to write this is f of 2 plus delta x minus f of 2 over delta x. But because delta x it's a lot to write sometimes, usually just use h instead of delta x. So you find it as limit as h approaches 0 of f of 2 plus h minus f of 2 over h. And that brings us to the definition of the derivative. And keep in mind the derivative is just the slope. That's what a derivative is. So the slope of f at any value on its domain can be evaluated by limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists. For all x which the limit exists, f prime is a function of x. This, when you have a tick mark right here, this is read as f prime, and it means the derivative of f. The derivative can be used to determine instantaneous rate of change. So not the rate of change between one point and another, that's average rate of change, but instantaneous rate of change is when you have just one point and you want to determine the slope of the graph. There's some different ways to write derivatives. You have f prime of x, which you just saw. You have d over dx of f of x. This d over dx basically means like the derivative of you have y prime and dy over dx, which is basically the same as these, except it replaces the f with y. So let's actually find some derivatives. So first I'm going to write this equation on the side that we're going to use to find the derivative of x squared minus 3x. So first, how do you get started on this? Well, if you just plug in 0 into here, if you just plug in 0 for h, you get f of x minus f of x over 0, which will just give you 0 over 0. So we can't just plug in 0 into there. We're going to actually have to plug in the numbers and do some math. So the first step is to replace your f of x plus h and your f of x. So we have our f of x right here. Now what do we do for f of x plus h? You replace all the x's with x plus h. So in other words, this f of x plus h would just be x plus h squared minus 3 times x plus h, because we're replacing our x with x plus h, minus your f of x. So you can just write that down here, all over h. Now we can start to simplify this and try to evaluate it like a normal limit. So the first step is to expand this by, well, first you're going to square this x plus h That's going to come to be, if you FOIL this, it's going to come to be x squared plus 2hx plus h squared. Then we have this minus 3 times x plus h. We'll expand that out to minus 3x minus 3h, because it's negative 3 times h. And then minus x squared plus, because we have two negatives here, plus 3x all over h. Now we can start to cancel out some of the like terms. We have x squared, and we have a negative x squared. Those will cancel out. We have negative 3x and positive 3x, and those will also cancel out. And here we have nothing else to cancel out, so we're just going to write these down. 2hx plus h squared minus 3h over h. Notice that all of these top terms have an h in them. So we can factor out the h. So 2hx over h is just 2x plus, factor in h is h, and factor out the h from there, so it's just minus 3 over h. And the h on the top and the bottom cancel out. So we're just left with 2x plus h minus 3. Now we can finally substitute in 0 for h to get 2x plus 0 minus 3. We're going to end up with just 2x minus 3. And that's the derivative of x squared minus 3x. What that means is if you plug in a value for x here, let's say 2, then you'd have 2 times 2 minus 3, which 2 times 2 is 4, minus 3 is 1. So the instantaneous rate of change, the slope at x equals 2 of x squared minus 3x, which is this function we were evaluating earlier, the slope at x equals 2 is 1. Okay. Now let's try the same thing with another function. The derivative of 2 over x. So we're going to start by writing out our derivative equation. We do the same thing as we did the last time. We're going to substitute x plus h into x to get our f of x plus h. So that's 2 over x plus h minus 2 over x over h. Now you're going to evaluate this like a normal limit. So there's the common denominator 1. You need to multiply this side by x and this side by x plus h. To have a common denominator. Now I can combine these two fractions. Now let's simplify this. So when as h approaches 0, 2 times x plus h, so 2x minus 2x plus 2h over x times x plus h all over h. Let's keep simplifying it, distributing this negative sign out. You get positive 2x and negative 2x. Those are going to cancel out. And now these h's are going to cancel out because this h is in the denominator and this h is in the numerator. So you're going to be left with limit as h approaches 0, negative 2 over x times x plus h. Now you can finally substitute 0 over h. You get x times x plus 0. There's negative 2 over x times x. There's negative 2 over x squared. And that's the derivative of 2 over x. Now if you don't know how I did this part, let me explain this really quickly. You have your negative 2h over x times x plus h. And this h is the same thing as h over 1. You're going to flip it around and multiply it times 1 over h. Because you have 1 on the numerator, 1 on the denominator, those are going to cancel out. That's why I got this right here. Now to the next one. Let's get the derivative of square root of x. Again, off in the corner I'm going to write our derivative equation. So now I'm going to get to solving this. First we're going to find our f of x plus h. We're going to replace x with x plus h. So you're going to get square root of x plus h minus square root of x over h. And remember, when you're solving this one with all the square roots, we're going to multiply by the conjugate. So square root of x plus h minus square root of x times square root of x plus h plus square root of x over h times square root of x plus h plus square root of x. Remember this plus right here, this is the conjugate of this square root of x plus h minus square root of x right here. Now we're going to simplify this. If you FOIL this out, you get this squared minus this second term squared, because there's a difference of two squares, right? So you have square root of x plus h squared, that's just going to be x plus h, minus square root of x squared, that's just x, and you leave the bottom intact. You have a next x and a negative x, those are going to cancel out. So h over h times square root of x plus h plus square root of x. Now the h and the numerator and the denominator are going to cancel out. You get 1 over square root of x plus h plus square root of x. Now you can substitute 0 for h. Take 1 over square root of x plus 0 plus square root of x, which is just square root of x plus square root of x. And that's 1 over 2 square root of x. Now this particular one, the derivative of square root of x, is going to be very, very useful to memorize because it's going to be used a lot. So just make sure to memorize that the derivative of square root of x is 1 over 2 square root of x because you're going to be using it a lot. And one last thing, vertical tangent lines. What that means is when you have a tangent line to the graph, and it's completely vertical. Like at x equals 1, this graph has a vertical tangent line. The definition of a tangent line to a curve does not cover the possibility of a vertical tangent line. For vertical tangent lines, the slope does not exist. we have, therefore, if limit as h approaches 0 of f of c plus h minus f of c over h equals infinity, so in other words, if the slope equals infinity, then the vertical line x equals c, which in this case c is 1 right here. The vertical line x equals c passing through cf of c is a vertical tangent line to the graph of f, and f of is not differentiable at x equals c. Not differentiable means you can't take the derivative at f equals c.